NAND is a universal logic gate that can make any function. There's also NOR that is considered as a universal logic gate. XOR and XNOR, they are verification telling whether the input bits are the same or not. On the first picture on the left, you see how to make a universal gate with verification gates. So every branch there goes back and forth, and it's eventually some kind of voting process where one of them is voting 0 and the other two would vote something, and the result is flipped. So it's an AND. The picture on the right has some universal gate, but made with an AND and an OR. So those are reducible to wires, and therefore the entire circuit there becomes wires. On the picture, we represented those wires with numbers, so the pins having the same numbers are connected with a wire. To function, it needs to send a signal from the output. It would receive it back, so it sends a signal, for example, from the 3 and 1, and it would receive it back on the 5 or on the 2, but not on both.
Proving that all logic could be made with wires got the switches out of the logic, and it is by now on the surface. So this NAND, for example, is having 4 switches that are outside of the logic as inputs. You can see now an equivalence between the switches and the transistors. So for example, a switch that connects 1 with 2 or 3 with 4 is equivalent to 2 transistors that would connect 1 with 2 or 3 with 4. I mean, having on the base some signal that tells them to connect the emitter with the collector or not to do that. Once those functions of wires are combined together to have an addition, for example, we can notice that an input isn't 2 switches only. It's 2 switches that are reproduced many times, connecting different wires together. The ones that are on the same line would behave the same way, as they represent the same input. Memory effects come with linking the output back to the input. On the following circuit, for example, that we've already seen, the siren is connected back to the inputs, and that would mean that opening the door would ignite the siren, but shutting it down would not put the siren back off. It would require the alarm off to shut it down. That it remembers whether the siren was on or off when you shut back the door. Connecting the outputs back to the inputs can have this memory. Any input that is connected to the output has to be made out of transistors, that those buttons are governed by the output and cannot be triggered by a normal switch. For the rest of inputs, we could always have them synchronous with a physical switch, and therefore they are optionally transistors.